Okay, so today we're going to talk about adding and subtracting rational expressions. So we're going to start with an example from 5th grade. We are going to add 3 over 10 and 1/2. So the problem is if you're trying to do this without a calculator, which you're going to have to do when you have variables, you can't use a calculator to do it for you. What you're going to do is you're going to add the fractions and you need a common denominator, okay? So when you're trying to find a common denominator, there's a couple of ways you can do it. Now, if you have numbers, you can just list like multiples of that number. So if I'm looking at the number 10 and I'm looking at 2, I could make a list of 10, 20, 30, 40. I could do 2, 4, 6, 8, 10. You could do it that way. That's kind of very elementary school. But what you guys need to do is you need to get used to listing factors, okay? Not so much with the numbers, okay? Yes, numbers are part of the Math 3, but you need to start looking for things that are in common and things that are not in common. So what I did is I created a prime factorization for 10. It's just 2 times 5, super easy, okay? And then 2 is just 2. So if you noticed on the screen, I have the 2 highlighted. This is what is in common. So this is known as a common factor. So 2 is in common, 5 is not in common, it is leftover. So what you do to find the least common denominator, which is also known as least common multiple, that's what you were taught in elementary school, is you multiply what is in common times what is not in common. So I have a 2 in common, I have a 5 not in common, so 2 times 5 would give you 10, okay? That seems really complicated for these numbers, but that's the process that you have to use on polynomials, and that's why I'm explaining it to you with the easy numbers right now, okay? So let's just kind of review real quick. If I want to take 1/2 and I want to write an equivalent fraction, what I would do is I figure 2 times 5, and you're going to have to write the 5 in there. So 2 times 5 gives you 10. So what you do to the bottom, you also have to do to the top. So 1 times 5 is going to give you 5 over 10. So we did practice writing equivalent fractions the other day, okay? So I'm just going to change the fractions to equivalent fractions. Therefore, I can go ahead and add a cross. Just make sure that you realize that you're only able to add the numerator together. So it's going to be 3 plus 5, and that's going to give you 8 out of 10. So all of this process is the same with polynomials. Now at the very end, you have to look at your 8 out of 10 and see if you can simplify it, and you can. So you do need to give a simplified answer. All right, let's look at the second one. Now this is very different when you have polynomials. You can't just type it in your calculator and then poof, let it be done, okay? So this one is a subtraction problem, and we have to be very, very careful when we are subtracting, especially if you're subtracting more than one term. Okay, so what I'm going to do is I'm going to look at each denominator. So this is x plus 3. That is a binomial, okay? So when you're working with your rational expressions, you need to make sure that you are treating monomials and binomials and trinomials differently, okay? So I have a binomial that is x plus 3. I have a binomial that is x minus 2. Do I have anything in common? So when I'm looking for binomials, it's got to be all the binomial. I'm not looking just for x. I'm not looking just for 3. I'm looking for other x plus 3's. I don't have anything. So these two have nothing in common. So I'm going to take everything and multiply it together. So everything's left over. So nothing's in common. My leftovers would be x plus 3 and x minus 2. That is your LCD. It's actually pretty easy once you get a lot of practice, okay? So if that is your least common denominator, this is going to be your goal. This is what you're going to have to do to each fraction. So the first fraction right here, this is your goal, and this is what you started with. So you started with 2 over x plus 3. What do you need to multiply times x plus 3 to create an equivalent fraction? You already have an x plus 3. I need to multiply it by x minus 2. So this is what I need right here. So what you need, I'm multiplying to the denominator. You have to do the same exact thing to the top. If you want to go ahead and multiply the 2 times the x and the 2 times the negative 2, you can. I would actually go ahead and suggest that. So let's write that in. So we're going to multiply, we're going to distribute 2. So 2 times x, and then we're going to do minus 4. Now, if you notice, a couple of lines lower, I put the 2x minus 4 right here. Okay, now we're going to do the second one. So on the second one, I need to take this x minus 2, and I need to create this denominator. So what do I need? I need an x plus 3. So I'm going to take this x plus 3, multiply it to the top as well. So that means I'm going to have to distribute the x. So that's going to give me x squared plus 3x. And then as you can see right below it, I put that right here. Now that looks super complicated, but really all we did was we created a common denominator of x plus 3 and x minus 2, and then we wrote equivalent fractions, okay? So now what we need to do is we need to look at this, and we want to subtract the first numerator and the second numerator. Notice how I have 2x minus 4 right here, 2x minus 4, absolutely no changes. But you need to be very careful when you're subtracting. So you see this little minus sign right here? Watch how I wrote it. When I combined both fractions, I put a minus here, but then I put this group in parentheses. Now, why would I do that? When you're subtracting the second fraction, you see that you have 2 terms on the top. So technically what you're doing is you're going to subtract x squared, and you also have to subtract 3x. So if you notice below, I showed you that transition. So you are subtracting x squared here, and you are also subtracting 3x. So if you have more than one term in the second fraction, make sure you subtract each term. Could it be possible that you subtract a negative term? Absolutely. So if you subtract a negative term, that's going to change into plus a positive. So be really careful. That's kind of like the number one little bitty mistake people look over. Then all you've got to do is look at the top right here and just write everything in standard form. So this is first, right here. And it looks like I've got a couple of like terms here. So 2 minus 3 gives you negative 1. And then to finish it out, I'm going to write the negative 4 here. So just write it in standard form. And at the very end, you have to check if your numerator is factorable. If it is, factor it and see if you can simplify. If not, then you're done. And this problem is not factorable, and this is complete, okay? So don't flip out. This is one of the most difficult ones right here, but we're going to have a lot of practice, so don't worry about it. Okay, flip it over on the other side. I've got another example worked out for you with less explanation. Okay, so we start with this right here, and it looks very intimidating. So look at the first fraction. I have a denominator of x minus 6. It's just a simple x minus 6 binomial. I can't factor it. I'm just going to leave it alone right now. But look at the second one, though. See how you've got 3 terms? Is this something that we could possibly factor? Yes, okay? So sometimes you will have to factor the denominators. So all I did is I just simply used trial and error, and I factored this trinomial into these 2. So that factors into x minus 4 times x minus 6. Then you kind of go into step number 2. So you have to look for a common denominator. Now look at your denominators now. Do you see anything that you have in common? You have an x minus 6 here. You have an x minus 4 here. And you have an x minus 6. So look at the first fraction and look at the second fraction. We have an x minus 6 in common, don't we? They both share the same binomial. So this is the one that's in common. That x minus 4 is kind of all by itself over there. So he's left over. So he's not in common. And all you have to do is multiply what you have in common times what you have not in common. Now notice how I don't FOIL that out. That's actually good news, okay? So whenever you find your LCD, keep it factored. It makes life easier. So I'm going to keep it factored. And then here I am creating an equivalent fraction. So this one already has the least common denominator. I don't have to change anything in that second fraction. But the first fraction is missing part of it, right? It's missing the x minus 4 part. So I'm taking the x minus 4, multiplying it top and bottom, and I just want to make sure that you're following me. So you see this right here? How did I go from the top to that 4 terms? What did I do? What technique did I use to get 5x squared minus 20x plus 1x minus 4? What did I use? We distributed, we FOILed it, right? So when you multiply a binomial times a binomial, you have to do first, outside, inside, last, okay? And then I just combine like terms, and that's it. So the numerator is not factorable. I'm done. So as you can see, there's a lot of steps to adding and subtracting. They're not all going to be that bad, I promise. Okay, so what we're going to do is we're going to practice finding the least common denominator. So this is the very first step. We're going to try to factor. So step number 1 says to factor, and you only have to factor the denominators. And it should be very basic factoring too. It's going to be probably trial and error, maybe some slide and divide, some greatest common factor stuff, probably not any grouping or anything like that. Maybe some difference of squares, but that's pretty much it. Okay, the second thing we're going to do is we're going to look for what we have in common and what we don't have in common. So make sure that you're comparing monomials to monomials, binomials to binomials, and trinomials to trinomials. And then we're going to multiply what's in common to what's not in common, and then we're going to stop, okay? So let's look at number 1. Now, if you notice, the denominators are monomials. So the denominators are monomials. So what you can do is you can think of them as separate parts. So that means 3 times x, right? You know that. I'm just writing it down for your notes so you can see it. Now the 8 is, if you break it down, that's 2 times 2 times 2, and then you have an x, okay? If you're really good with your numbers and you can find the LCD for your 3 and your 8, you don't have to break it down, okay? But when you do break it down, you see that you only have that single x that's in common, right? So take a highlighter, and I want you to highlight what we have in common. So we're going to highlight the x and the x. So I'm going to write common. And if you look at the first fraction and the second fraction, none of the numbers are the same. So if you want to, we'll just say not common. It's basically everything else. So it's the 3, the 2, the 2, so it's really 3 and 8. So 3 and 8 have absolutely nothing in common. So all you've got to do to find your least common denominator is multiply the 2 together. So your LCD is going to be x times 3 times 8, which is 24x. There you go. Okay, so let's look at number 2. I have a denominator here, but this one's looking kind of weird. What's the denominator on that 7? I don't see it. Yes, it's a 1. So if you have a whole number, if you don't see the denominator, make sure that you put the little 1 in there. Okay, and you look at them separately. Do we have anything in common? Well, the first one's a binomial, and the second one's not even a binomial, so they can't have anything in common. So I'm going to put NA. And then your leftover, so not in common, would just be x minus 2. I'm not even going to bother putting the 1 in there because it doesn't affect anything. So my LCD, so my common denominator, it's going to be what I have in common, which is nothing, times what I have not in common. So I'm just left with good old x minus 2, and that's it. Okay, so let's take a look at number 3. So I'm going to ask you a question here. can I factor x plus 5? Do I need to do trial and error, difference of squares, or any of that good stuff? No. Okay. So what about the second one, though? Can I factor the second denominator? Yes. Okay, so I'm going to pause the video, and I'm going to let you factor it, and then talk to your group, make sure that you all have the same factors, and then we'll come back. Okay, so I factored that into x minus 5 and x plus 5. Now, when I factor that, just a friendly little hint, I'm going to mark this out to where I don't see it anymore because we don't need that anymore as long as you factored it properly. Now, I want you to look across from the first fraction to the second fraction. Do you see anything in common? Nod your head yes or no if you see anything. Okay, what do you see that's in common? X plus 5, yes, good. So I am sharing an x plus 5. So I'm going to put what's in common here. Okay, now do I have anything that's left over that's not in common? We all see. It's x minus 8. Okay, so here's the good news, okay? If you're finding your least common denominator, all you have to do is multiply them together, but you don't have to simplify. So if you have binomials, if you have trinomials, just write them together. So we're going to leave it x plus 5 and x minus 8, and that's it, okay? Okay, moving on. So let's look at number 4. Is there anything that I could possibly factor in those two? Nope, they're already binomials. There's nothing going on here, and you know what? It looks like I don't have anything in common, right? Everything is left over. So is this something maybe you can do in your head? Can you find that LCD like super fast? Okay, so I have nothing in common. I'm just going to put not in common. And if you don't have anything in common, then that is actually also your LCD. Okay, and then I'm going to let you guys tackle number 5 on your own. So look and see if there's anything that you can factor, look for what's in common, look for what's not in common, and then find your LCD. Here we go. Okay, so it looks like we factored the first denominator into x plus 2 and x plus 4, and I do have an x plus 2 in common, so I put that there, and then I don't have anything in common with x plus 4, so I just wind up multiplying together, so your LCD is x plus 2 and x plus 4.